In this video, we're going to learn how to balance redox reactions in an acidic solution. The easiest way to do this is to use what's known as the half equation method, and I've listed out the steps of this method in this bubble here. So I've boxed up in blue a typical redox reaction which you may be asked to balance in an acidic solution. So the first step in order to utilize this half equation method is really to split up this overall redox reaction into its half reactions. And in order to do this, you kind of look at the reactants and products and you see which elements are contained in common pairs. So here we've got a dichromate ion, and then over here we've got a chromium ion. So they both have chromium, so I'm going to pair those together in a half reaction. And then in this nitrous acid you see a nitrogen, and then over here in the nitrate ion you see another nitrogen. So I'll pair those together in a half reaction. So clearly both this overall redox reaction and these half reactions are unbalanced. So in step one, what you have to do is balance elements other than oxygen and hydrogen. So over here we had 2 chromiums, and then over here we only had 1. So I actually have to make this into a 2 over here, and that's what I did in order to fix that. So I balanced the chromium, and then in this nitrous acid going to nitrate equation, the only elements other than oxygen and hydrogen are nitrogen, right? And there's 1 over here and 1 over here. So I did not have to make any adjustments for step 1 for this half reaction right here. Okay, in step 2, you have to balance oxygen by adding water to the opposite side. So let's go back to step 1 and see how I would get to step 2. So in step 1, I have to balance oxygen by adding water to the opposite side. So in step 1, I've got 7 oxygens on the reactant side for this half reaction and no oxygens over here. So to balance those 7 oxygens, I'm going to actually add 7 waters to the product side. And that's exactly what I did. You can see I added in 7 H2O to the product side. Okay, in this second half reaction, we've got nitrous acid going to NO3 minus or nitrate. And you can see I've got 2 oxygens over here and 3 oxygens over here. So I'm actually going to add 1 water to the reactant side in order to balance out the oxygens. Now I've got 3 oxygens over here and 3 oxygens over here. Okay, moving on to step 3, balance hydrogen by adding hydrogen ions to the opposite side. So again, let's look at step 2 to see how I got to step 3. So in step 2, we want to balance the hydrogens to get to step 3. So the hydrogens on the reactant side over here are 0, and then over here, because we added the water, are now 14. So we've got 0 hydrogens over here, 14 over here. So I'm going to have to add 14 hydrogens over here to balance them, and you can see that's what I've done here. Okay, in this next reaction, we had 2 hydrogens from the water on the reactant side, plus 1 hydrogen from the nitrous acid, so 3 hydrogens on the reactant side here. No hydrogens over here, so I'm going to have to add 3 over here in the form of H plus ions to balance this out. Alright, awesome. Step 3 is done. So step 4, we have to balance the charge now by adding electrons. So let's look back at step 3 to see how we get to step 4. So in step 3, let's check our charges. So we have to make sure the charges are the same on the reactants and the product side for both equations. So in step 3, we've got 14 plus 2 minus. So on the reactant side right here, this is an overall plus 12 charge, right? So over here, what is our charge? 2 times 3, 6 plus, and then the water is neutral. So 12 plus versus 6 plus. What does that mean if I have to add electrons to balance the charge? That means I should add 6 electrons over here to make this 12 minus 6 equals 6, right? To balance out the charges. Now they're both plus 6. Okay, for this second equation here, my charges on the reactant side here are actually neutral. We have a 0 charge on the reactant side. And then on the product side, we have 3 plus and 1 minus. So on the product side, we now have a plus 2 charge. So in order to balance that with the neutral charge of the reactants, we're going to have to add 2 electrons to the products here, and that's exactly what I did. So now it's a 0 charge over here and a 0 charge over here. So step 4 is done. Step 5, now we have to multiply each half reaction by the appropriate factor to balance the electrons. So what that means is that we've got 6 electrons had to be added to the first equation, while only 2 electrons had to be added to the second equation. And we want it to be the same number, right? Because all the electrons that we put in have to be the same amount of electrons that we get out. So in order to change this 2 into a 6, I'm going to multiply this whole equation here by 3. See, I multiplied, in this case I only had to multiply one half reaction by the appropriate factor to balance out the electrons. Sometimes you'll have to multiply them both by a certain factor. So I'm going to multiply this equation by 3. So I do that in step 5. And you can see I'm going to distribute this 3 onto every term, and every coefficient is going to be multiplied by 3. And this was the result that I got right here. Okay, so now they have the same number of electrons, right? We had 6 electrons in the first reaction, 6 electrons on the product side in the second reaction. So now we need to add the half reactions together and cancel out common terms, in addition to canceling out the electrons. So this is the final step. So in step 6, I added together this first equation here, and we already had that up here. I just brought it down here. And then I had to add that with this second equation that I got from right here after I multiplied it by 3. And I simply add together all the reactants and then add together all the products. And this is the giant resultant equation down here. And now I just cancel out what's common to both sides. So I canceled out 3 waters because they appeared on both sides. I canceled out 3 here, and there were 7 over here. So if I cancel out 3 of those, that goes to 4. Then I noticed there were 6 electrons on both sides, and that's what we expected. So I canceled both of those out. Then I noticed there were 9 hydrogens on both sides that could have been canceled out. So I canceled out 9 here, turning this 14 into a 5, and then I canceled all 9 of them out here. And then after I crossed everything out that could be crossed out, I rewrote the final balanced redox reaction cleanly down here in this black box. So as you can see, it's a very involved process, but as long as you follow this like a cookbook recipe, you will always get the right answer. So this is how you balance redox reactions in an acidic solution.